In number 25, we have repeated percent change. Let's draw a little diagram, a little picture of what's going on here. We're starting with a price of an item in January that is going to be P dollars. And we want to know what the price is in April. So I'm just going to write my other months here, February, March, and then April. With the key being it's going to decrease by 10% each month. So from Jan to Feb, it's going to go down by 10%, down by 10%, and then down by 10%. And I want to know what is the price in April after these decreases. With the shortcut, this percent change shortcut, which is so critical on questions like these, it's not going to be too bad. So we take our original price and we multiply it by 1 plus or minus r, plus if it's increasing, minus in this case if it's decreasing, and then r is the percent change in decimal form. So we're just going to apply this percent change 3 times. So we're going to start with our price, P. I'm going to decrease it by 10%, so I'm going to multiply it by 1 minus 0.10. And that's the same thing as just 0.9p when we clean that up. And that will get us the price in February. I can then take that price, do the same thing, right? We're going to do 0.9p times 0.9 times 1 minus 0.10, and that would get us 0.81p. And then I can do the same thing again, 0.81p times 0.9 to get us to April, and that would get us 0.729p, and that's choice E. Now, actually, you could have done this in one step. We could have done p times 0.9 times 0.9 times 0.9, each of these 0.9s representing a 10% decline. You can also represent that as p times 0.9 cubed, and this, by the way, shows us how exponential change, exponential growth, exponential decay is just repeated percent change. You're just applying a percent change a certain number of times. But here, yeah, we can just do that, and if we go ahead and put 0.9 cubed in our calculator, we will, of course, get 0.729. So all this leads us to choice E. Another reasonable option would be to pick a value for p, and I think a good idea when you're dealing with percent problems and you're trying to plug in some starting numbers, while you can use any value you'd like for p, pretty much, 100 is probably a good idea. It's just easy to work with and easy to compare when you get a final result. So we're going to take our 100 and we're just going to go ahead and, again, multiply our 100 by 0.9 and then by 0.9 and then by 0.9. So multiply it by 0.9 cubed. That will get us 72.9. And again, this is the value of starting with 100. When we see, how does 72.9 compare to 100? If I plug 100 into these choices, we'll see, again, of course, it's going to be choice E when I plug in P as 100. So plugging in also is a reasonable option here. Some do nots, I suppose, we can add to this list. One failure point here, one mistake would be to think, well, if it's decreasing by 10% each month, I can just add up those 10%, 10%, 10%, 10%. That would give me a net decrease of 30%. And then we might say, well, if I take P and I multiply it by 1 minus 0.30, which is a 30% decrease, that would get us 0.7p, and that's choice D. But as we've seen before in other questions involving percent change, I can't really add and subtract percents. I have to deal with them individually, step by step. So I can't add 10 plus 10 plus 10 to get 30 and apply that. I have to apply the 10 and then apply the 10 and then apply the 10. And again, another reason why this formula is so important and so helpful. It kind of forces us to do that. Another thing that you could do, but I would definitely not recommend it, is not use this formula and instead apply your percent change in the multi-step way. In other words, you take your P and you subtract from it 0.1p, right? Because you're finding 10% of P, you're taking that result and then subtracting it from your original. And this would get you 0.9p. And then you could take 0.9p and do the same thing, subtract, well, it's going to be 0.9p times 0.1, find 10% of that. That will get you 0.81p, and so on and so forth. It's fine, it works, but it's obviously many more steps than just doing this. So again, while the multi-step way can work, very strongly recommend you use this formula. It's one of the most powerful and useful formulas in this unit, I would say. So make sure you know how to use it.